Oh, hi. Welcome to my live stream. Today we'll be seeing system design. We'll be reading the book, Klapman's book called Understanding. I don't remember the book name, but it should be in my recent files. Yeah, Designing Data Intensive Applications. Uh, okay, basically, this week, I'm trying to get it. I'm trying to get to a stage where I have a presentation ready for you guys. Or, I mean, not for you guys, but it's for me. I just want to explain things so that uh, maybe yeah, just have slides around it. And slides are on the first chapter this week. Okay, let's do it. So, meanwhile, I'll just write my notes as well. I'm maintaining a notes in uh, Notion, and I'll be transferring the notes to Anki later on. Hum. Okay, good start. Yeah, where is my Clubman book? Clubman data system design. Is this the one? Okay, this is the one. I have made some questions, but then I really want to do okay. Yeah, data intensive versus which is more problematic these days. Raw CPU power is rarely a limiting factor. It's all about data, how to handle big data, complexity of data, speed at which it's changing. Okay. A data intensive is typically built from standard building blocks that provide commonly needed functionality. For example, many applications need to store data so that they or another application can find it again later. Uh, okay. I think I'm just thinking from the perspective how should I read this? What's the best way to read this book? Maybe I should, after reading a paragraph, I'll try to see if a question comes up, can add to Anki, or I'll explain my thoughts as well. What do I think about it? Of course, not, I'm not very good at this, but I think I can give some ideas, good ideas. First of all, I'm so lucky and feel blessed. I mean, I like this book so much. I just can't. Yeah, I wanted to read this like for years. For from the past 1 year, I'm trying to read this book, but I'm not getting time. But today, this from today, I'll be reading. Data intensive application is typically built from standard building blocks that provide commonly needed functionalities. For example, many applications need to store data so that they or another application can find again later. Remember the result of an expensive operation to speed up reads. I think it's saying the definition of like simple definition in the layman terms. What's a database? So you store data from usage of a database is mainly the main purpose is to store data from one application, and it can be used later within the application or in another application. Or what is a cache? Cache is used when uh, there are multiple access levels, and you are able to access, you want to access something, some expensive operation faster, you move the access, the item to be accessed to a place where you can access it faster. Allow users to search data by keyword or filter it in various ways. So search is like, Google search. Yeah, it's one of the, I think, search in computer science is one of the most discussed thing. Um, so if you're searching data by keyword, they need to be optimized for specific things. So you have some index for each keyword or things like that. So search indices are help with that. Maybe we'll read in the next chapters what they are. Um, Send a message to another process to be handled asynchronously. Uh, okay, this is like peer-to-peer communication where you send a message, or it's like sending a message in WhatsApp to your friend, and they acknowledge, not, they don't need to acknowledge immediately. They can acknowledge at any point of time. So that's the synchronous communication. And uh, what if you send streams of messages? We humans send only like some messages at time, but computers need to communicate, or two data systems need to communicate and send a lot of data for processing. Uh, so they stream the data from one system to another, and it can be asynchronously connected, like read the data. So this is stream processing. I think we have Kafka streams for this, or Redis streams. Redis also can take care of this. But let's see what the author mentions in his book. Periodically crunch a large amount of and accumulated data. Okay, yeah, it's more of processing. For there are for analytics, like data analysts process batch data, so they process huge amount of data on single query. Uh, so it's more of how to do that, I guess. So periodically crunch a large amount of data. Nothing to be written here because it's fine. We'll read the same thing again. If that sounds painfully obvious, that's just because data systems are such a successful abstraction. We use them all the time without thinking too much. Most engineers wouldn't dream of writing a new data storage engine from scratch because databases are a perfectly good tool for the job. Of course. But reality is not that simple. There are many database systems with different characteristics because different requirements, applications have different requirements. There are various approaches to caching, several ways of building search indices, and so on. When building an application, we still need to figure out which tools and which approaches are most appropriate for the task at hand. It can be hard to combine tools when you need to do something that a single tool cannot do alone. Okay, that's all for today. We read the first page, the first chapter. Uh, I guess, I mean, I already read the first chapter once, but I'm trying to make slides out of it, so let me read it again. Uh, yeah, it's about basics, maintainability, availability, operability. Hmm. good. Jeffrey Dean is who? Is it our Jeff Dean guy? Oh my god. This is also good. I mean, I want to read all the references, but uh, then I want to first complete the book. I mean, obviously, I will not have time to go through all. But yeah, if something comes up, I'm not sure which are important. This is down completely. Okay, that's fine. That's all for today. I'll continue tomorrow. See you. Bye.